Welcome everyone to this week's Fish Friday. Today we are on Fish Friday number 27. How about that? 27 weeks. Today we have a fish that many of you have heard of the group of fish, and chances are, if you grew up watching a Pixar movie, you've seen this fish before. We are going to talk about the orange clownfish, and that's very particular. We're talking about the orange clownfish. Just for your own education, I believe Nemo is based primarily on the false percula or the common clownfish. So, no, I wouldn't say it's Nemo, but it's Nemo-ish. All right, orange clownfish. The scientific name is Amphiprion percula. They are part of the family Pomacentridae. Pomacentridae is your family of damsels and clownfish. So your damselfish and clownfish. Now there are actually 30 different species of clownfish, for those of you who didn't know. So definitely be aware, kind of look. There are ways to tell them apart. They're not great ways I have very little knowledge of clownfish, but I know you can tell them apart. Now, orange clownfish are found in Australia. More specifically, I believe they're much more common in the Great Barrier Reef. I don't think they're found very other places, but I think they're very common in the Great Barrier Reef. But they are probably common throughout the sort of southwest Pacific sort of area. Now, orange clownfish will get to about 11 centimeters, which is about 4.5 inches max. So, you know, that's about a max clownfish or orange clownfish, but normally you're going to have them average about 8 centimeters or about 3 inches. And how you know that how a clownfish is an orange clownfish? So, as with a bunch of clownfish, they have 3 white bars, or white lines if you want to call it. And on these white lines, you have one that's right behind the middle of the eye. Then you have one right in the middle of the body. And you have one right at the caudal peduncle, which that's right where the tail fin meets the tail, actually. And another way is the middle band has this anterior, so front-facing, and bulge right here in the middle band. It's very, very distinct. There are 10 spines in the first dorsal fin. So I don't know if they have a split dorsal or if it's one continuous dorsal, but I know at least on the front part of their dorsal fin, they do have 10 spines, whereas the false percula or the common sort of clownfish, that has 11, I believe, not 10. Now, also something about this is there are black edges on the fin, on every single fin. Not just 1 or 2, on every single fin. They vary in thickness, but there's this black edge right here. Now, of course, like many clownfish, they are associated with anemones. More specifically, the orange clownfish is associated with Heteractis magnifica, don't know the common name, sorry, and Stychodactyla gigantea. Here's one picture of it. I do know the common name of this one is called a carpet anemone. So, and look here, these are some color morphs of orange clownfish, I believe. That's another thing about clownfish. They have all different kinds of color morphs and things like that. These are orange clownfish. Look at these. Right on that. How can you not do this? These are a type of clownfish, but these are obviously not orange clownfish. I don't know what these are. I'm sorry, guys. So, now about how the clownfish interacts with the anemones. So, as I said, they're associated with anemones. The anemones actually protect the fish from predators, as many of you are probably aware. Anemones have stinging, these little tentacles of theirs. They're actually they have what are called nematocysts, which are very tiny spines, basically, that will shoot into the skin of an animal to cause a really stinging reaction. They're essentially getting stung. It's more of a poison, I believe. No, it's more of a venom than an actual stinging, but yes, basically 10 billion hypodermic needles. So the anemone will actually protect the fish from predators, and the fish will in turn feed it, oxygenate it, and remove big waste from the anemone. So if something falls on the anemone, it'll push it off. If like rock happens, they'll remove it. But a fish will actually come in and feed it. You know, it's a very symbiotic, mutualistic relationship. That doesn't necessarily, all symbiotic relationships don't necessarily have to help each other, but this is a symbiotic mutualistic, meaning that both of them are helping together. And it's very important that this fish find this anemone. And the reason why is because clownfish associate with very specific anemones, and there's been studies figuring out why. And originally, it was thought that the mucus of the fish, well, let me rephrase that. Long ago, it was thought that this particular clownfish, or all clownfish, were just immune to the toxins of the anemone that they're associated with. And then it was discovered that they have a mucus layer, and then that mucus layer actually will prevent the discharge of nematocysts. So then they were like, well, the mucus layer is what causes it to not be stung by the anemone. And it turns out it's actually kind of a combination of both. There is a mucus layer that does actually prevent the discharge of nematocysts. However, the clownfish is actually immune to a small amount of the toxins from the anemone. It's not an absolute massive amount, because if you remove that mucus layer, which, by the way, that is why you should never, ever handle a fish with dry hands. Never handle a fish with dry hands. That is a good way to have your fish catch an infection or cuts. It's really, really bad. Now, as far as what the orange clownfish eats, they kind of eat anything that they can get on. They'll eat small copepods, small shrimp, small fish. They kind of eat just about anything. And in fact, in times of starvation where there's not a lot of food available, they'll actually go through and they'll eat some of the anemone tentacles. Just so that's another example of the symbiotic relationship. The fish eats the anemone tentacles, not all of them, but it eats one or two to basically survive. And in turns, that fish will produce waste, fish poop. And that fish poop is what the anemone will absorb into its body for nutrition. Now, reproduction. Reproduction of clownfish is very, very interesting. There's no other way to do it. So near the anemone that the fish lives in, they will either find or they will actually bring, by literally dragging, a flat or a bowl-shaped rock next to the anemone. And then they will lay their eggs on that sort of rock, or that bowl. And then the male will actually pick through the eggs and find any bad eggs or eggs that are messed up, and will eat them. That just eats them. He does that, and he picks those bad eggs out of there, because when fish eggs are laid in a cluster, if you have one bad egg that dies and then starts decaying, it can get rid of the entire clutch of eggs by just sheer proximity to it. Now, something that many people have heard of is, all clownfish are born male. There are no females born in a clownfish. At least in the orange clownfish. I think it's for all clownfish, but there are no females actually born. They're all born males. And breeding is done always between one male and one female. However, these can be in groups actually. And so you'll have one male, one breeding male, one breeding female, and then you'll have 0 to 4 non-breeders, non-breeding males that are around, that are in their little group, that are nearby and things like that. and it's a hierarchy. The largest, so think about it, you have 5 fish. The largest male will become a female. The largest fish in the group becomes a female. Then the second largest will be your breeding male. And then you have 3 that are non-breeding. And they will go and they will be staggered in size. This one will be bigger than this one. And this one can pick on this one, but he can't pick on anyone else. And this one is bigger than this one and can pick on him, but he can't pick on anyone else. And then there's this little one that's just trying to just get by. However, if the female dies, then this breeding male will actually change its sex to become a female. So the largest breeding male, the breeding male will become the female. And then the largest non-breeding male will then actually develop into a sexually reproductive male and actually become the breeding male. And then this one will actually grow in size to be a step down from the breeding male. So it's always in a tiered hierarchy. So it goes bam, if something dies, everyone moves up one rung on the ladder, with the absolute top ladder being female. So it's super interesting when you get into the protandry aspect of clownfish. Now that also goes into sort of the recruitment. Recruitment is how well young do, and the issue with clownfish is they really can't leave their anemone. They're very stuck to their anemone. If they kind of branch out, they sort of a lot of times just die. They get eaten. So many things eat clownfish. So how these animals actually spread and why they're found in such a small area is basically once the eggs hatch, the larva of the fish will go up, way up into the water column, basically kind of float there eating small plankton, and then they start getting a little bigger like after a week or so, and then they basically dive straight down, and they actually will smell the anemone that they are associated with. And then what they'll do is they'll circle that anemone getting closer and closer, and then kind of brush up against it and then back away, building up that sort of immunity and that mucus layer for that anemone. They'll just kind of brush against it and kind of back away until they get there, and then they'll enter that anemone, and then that's theirs. They will defend that to the death. Now, as I mentioned earlier, these can be found in the pet trade. They're very common in the pet trade. They're not. I mean, you can find these almost anywhere. They're regulated sort of by the Great Barrier Reef Marine Park Authority. I know they are the ones who regulate the number of collection permits, but these are very cheap. You can probably pick these up for about $15 or so, $15 US. So I wouldn't say they're uncommon. There's so many different color morphs. It's really hard for me to say that. I'm talking about your baseline sort of orange clownfish. However, if you get like the super melanistic ones or the white morphs, which have the bars just basically all over the body, you can get up to $150. I mean, it's crazy how clownfish can range inside. But your baseline, this fish kind of right here, would probably run you about $15, and you could probably find it at most saltwater aquarium stores. But thank you guys so much again. I really appreciate it, and I hope to see you again. If I don't, please be safe. Have a great day. Please leave a like, comment, and subscribe. If you do, I would really appreciate it. Please leave me a comment what you would like to see. I'm just waiting on comments. I definitely enjoy these, and we're going to continue doing them. And yeah, I haven't regretted this. 27 weeks, not one regret. But thank you guys so much again. Take care of yourselves, take care of your loved ones, and